Oh, got it.
There we go.
Boom. Yeah, thanks everyone for tuning in for a little meetup this evening. Thanks for having us. My name is Simon. We're from Froth Technologies.
I'm Ryan.
This is Ryan. We're both the co-founders of Froth Technologies. It's New Zealand's first commercial beer yeast lab. So yeah, we have both been in brewing in some way or another for about 10 years. Starting out as homebrewers like yourself, trying to make a tasty drop, or at least maybe a cheap drop, and then after that you work on making a tasty drop. And yeah, sort of I initially founded the Massey University Brewing Society here in Wellington, and we're doing sort of tutorials and beer events around that. I started a contract brewing label called Kakariki, and yeah, that was sort of being brewed at a brewery in Christchurch that Ryan was working at. So Ryan was, yeah, sort of cutting his teeth as an assistant brewer there, doing all sorts of things, and even recipe development and one-off seasonal brews and stuff. So yeah, I was sort of, my beers were being made down there in Christchurch, and so we thought about getting into business together, perhaps a brewery even. Ryan moved up here to Wellington, being a sort of bit of a central spot for craft beer in Aotearoa, and you started working at Garage Project's Wild Workshop.
That's correct.
Doing the slow motion beers, barrel aging, sours, fruited beers. And yeah, while we were sort of doing our market research and setting up, yeah, sort of having our eureka moment that said, when it comes to local ingredients, there's a bit of a gap there when it comes to yeast. And so, yeah, Froth Technologies was born from that. So that's us. This evening, we're going to talk obviously about yeast, and we're going to, yeah, we've got a bit of a contents page here, which we'll show you. We'll just share our screen here so you can see all that, and then we'll get into it. Anything else you want to add here?
Yeah, just I guess if we've got any questions, we'll do a bit of like a Q&A at the end of the presentation. So note them down or whatever, and we'll set aside some time to answer your queries.
You can even write them in the chat if you want, and we'll look at those at the end. Otherwise, yeah, just jot it down.
Sorry, I muted everybody, including you guys. There you go.
We're back.
There you go. You're back now. Sorry.
Sweet. Can you see our screen there? Give us a thumbs up.
Looking good.
Yeah, cool. Alrighty. Goodness, I need to move that out of the way. Sweet. So yeah.
Full screen. Yeah.
Cool. Right on. So yeast is the topic of this evening. And yeah, here's what we want to sort of run through this evening. We'll start by, yeah, I mean, I've done a little bit of an intro there about how Froth Tech was formed, but we'll tell you a little bit more about what we do. We'll go into a bit of 101 of yeast and sort of how important it is as an ingredient when it comes to making beer. We'll go a little bit deeper into mastering your yeast. We've got some info about pitch rates and other factors around yeast health, nutrition, and as well as starters and cropping, yeah, so yeah, harvesting and then repitching yeast. And then yeah, towards the end there, we'll look at yeast and hazy beers, because we tend to get a fair few questions about that being a popular style at the moment, and haze retention being a little bit elusive sometimes. And then at the end, we'll give a wee update on where we're at with working towards getting homebrew pitches market ready for you folks. Cool. Let's crack into it. So this is our custom yeast propagation facility in Lower Hutt, Wellington. You can see top right there, that's our main production equipment. So it kind of looks like a brewery. The far left tank is a hot liquor tank. Next across on the right is the boil kettle, but this one is a pressure kettle. So we close off that manway on the top, and that motor, you can see the dark motor on the top, that stirs the vessel kind of like a mash tun. And we bring the pressure up inside of there beyond 15 psi, so the boil temperature goes up to 121 degrees. So we're sterilizing our wort rather than just sanitizing it at 100 degrees. So sterility and hygiene is just super important for us when we're growing yeast cultures. So we want to be even cleaner than a brewery, which is already a pretty damn clean place. To the right of that, you can see our biggest propagation vessel. So it kind of looks like a cylinder conical fermentation vessel. And beneath that, you can see 2 flasks. That's in our laboratory or our yeast nursery. We start our propagation process with just an agar plate with single colonies growing on it, and we introduce that into small volumes of sterile wort, and each day we step up that volume just as if you were, I suppose, growing a starter at home. But once again, aseptic conditions, and we're just basically feeding the yeast, and as it eats, it grows, and we're growing that yeast population bigger and bigger, checking the health and the population along the way. And then once that we've kind of got those flasks full of yeast, they'll come out into the production area and go into a small stainless vessel, a larger one, around 100 litres, and then into that 1500 litre vessel you can see top right there. On your left there, that image is a cool wee device we use called the brew monitor. So we've got that in from the States, and that's just mounted on the side of that big tank on one of the tri-clamp ports. You'll see there's 2 valves at the top there with yellow handles. One is drawing from the tank, the other one returns to the tank. Inside that black shoebox looking thing is a wee pump, which is able to draw liquid from the tank, cycle it through the box, and return it. And so it does that every 10 minutes. Every 10 minutes. And as the fermenting wort inside of the tank passes through the box, it's got a number of different sensors inside of it. So it measures the gravity, pH, dissolved oxygen, pressure, conductivity, internal temperature, external temperature. So normally, in a commercial brewery or a home brewery, you've got to draw a sample and do your gravity reading, pH if you're looking at that, and same goes for a commercial brewery, usually at least a couple of times a day. So this box is really cool, really helpful for us, because we can sort of open our phone or PC and bring up the current fermentation from anywhere in the world and see how it's tracking, see how the gravity's coming down, and even get notifications to our phone if it's sort of falling outside of our target parameters, like something's going wrong, so we can kind of rescue it before it's too late. So that's kind of a cool wee device there. This is another one that we use in our yeast lab. It's called the Oculize. So this is a digital cell counter. It's a wee microscope you can see on the left there, and a wee slide. You can see some pink fluid in there, which is basically diluted yeast slurry with a bit of cell stain. So a kind of food coloring, which makes dead cells go pink in that case. And then on the right, you can see just a tablet, and on screen, you can actually see the yeast cells there. And the software that comes with that is able to count the yeast cells, the live cells and the dead cells intuitively with AI technology. So it saves us doing the manual clicking over and over, and takes the human bias out of it. So it's, yeah, pretty cool digital cell counter there. But that's that's a bit about us. Do post any questions you might have in the chat about that, and we'll address them at the end. But let's talk about yeast.
Yeah, cool. Oh, we'll go back to that. Yeah, sweet. So when we're talking about yeast, I guess just a bit of classification stuff. So yeast is a single-celled fungus, and it's a eukaryotic organism, which means it has a nucleus encased by a cell membrane. So it's part of the fungus kingdom. And when we're speaking about yeast, there are over 1,500 known species of yeast, which is a heap. And they do a range of all types of different things when it comes to fermentation performance and their outputs and things like that. But for the most part in brewing, we're generally talking about two main species of yeast. Those are Saccharomyces cerevisiae, which is ale yeast, top fermenting yeast, and Saccharomyces pastorianus, which is lager yeast or bottom fermenting yeast. And both of these species have been domesticated by brewers through artificial selection over centuries and generations of working in the brewery to kind of adapt, to suit the role it needs to perform in a brewery. So a couple of those adaptations are things like that. Saccharomyces cerevisiae and pastorianus no longer sexually mate, and they don't sporulate, which means that their mutation rates are actually a lot lower than the wild yeast you'll find out in the wild. So yeah, they've been trained over a long time to suit our purposes for making tasty beverages. And primarily yeast is known for its role in metabolizing sugars, eating sugars, and producing carbon dioxide and ethanol, the booze. But there's a lot more that yeast does when it's doing its fermentation thing. It's arguably the most important ingredient in brewing. There are, of the BJCP faults that are listed, over 50% of them are directly attributable to fermentation. So, managing your yeast, looking after your yeast, it's a really, really key aspect if you want to take either an average beer to a good beer or a good beer to a great beer. And it's often one of the last things that brewers look at, just because, I guess, malt and hops are often easier to control. Yeast is a living organism, so it does take a little bit of extra care, but if you can, there's a few steps which we'll go through, which can really help to make them be happy and make great beer, which is what we all want.
Hell yeah.
Cool. So let me just hit that for next slide. So after we we pitch our yeast into our wort, which we've spent a few hours making, and mashed the malt, boiled it, added your hops, you go and chuck in yeast, and what happens next? So beer fermentation has three main phases. So the first one of those is the lag phase, which I think we go into there. Cool. So that is, from the minute you pitch up to usually around 15 hours after you've pitched. And during the lag phase, it's named that very appropriately because there's very little fermentation activity that you can detect. At this point, you're not seeing a drop in gravity. You're not seeing CO2 bubbling out of your airlock. By all means, things look like there's not much happening, but there definitely is. So the yeast is acclimatizing to its new environment. It's taking up nutrients. It's starting to metabolize the oxygen, which will use to help build its population. So it's a really key part in kind of setting the stage for a healthy fermentation. So there's no ester formation at this stage, none of those fruity aromas, but the lag phase does have a big impact on the development of precursors specifically things like the precursor for diacetyl. So it, which is an off flavor, which is undesirable in most styles. And it will also impact on that ester formation later down the pathway as well. So having a healthy lag phase, and we'll talk about that soon, is very important to determining the rest of your ferment. So temperature, nutrition, and oxygen all have a really key role in yeast development and the kind of health of each yeast cell. So making sure you get your work really nicely aerated as much as you can. In breweries, they're using direct O2 input. A lot of some homebrewers might be doing that. I remember back in my days, we were just sort of shaking the barrel as hard as we could, but that's a really good step. Temperature is important. If pitching warm will reduce your lag phase, pitching cold will increase it. With a good pitch rate, though, you should be able to pitch basically at your desired fermentation temperature, and that will be give you a good outcome. If you pitch too warm and kind of speed up your lag phase too fast, it can end up having negative effects on your brew later on. So that's kind of the lag phase. Sort of getting used to its new home, its new work environment, and soaking up all the nutrients and things like that. From there, we go into the exponential growth phase. So this is what we all recognize as an active fermentation. So at this point, the yeast has sort of gotten used to its environment, and it gets cranking on eating the sugars, metabolizing, and growing its population. So here we see a massive increase in cell numbers, cell density, and we start seeing that gravity drop and pH drop that is familiar to all of us who brew. So at this point, we're producing a lot of carbon dioxide, which is coming out of the airlock. We're producing ethanol, and we're producing those esters as well. When yeast is in this exponential growth phase, just a bit of, background on how the yeast works here. So it starts by attacking the simple sugars, the monosaccharides. Got that around the wrong way on that slide. The simple sugars like glucose, sucrose, and fructose. And then it moves on to maltose, which is the predominant sugar in wort. And it attacks the maltose by excreting an enzyme called maltase, which works to break down the maltose into simpler sugars that it can then digest more easily. And there's a lot of evidence to say that process of actually breaking down the malt sugars into more simple sugars is what gives us a lot of the characteristic flavors of a beer fermentation. So again, a very important step. So that usually lasts from when your lag phase finishes through to sort of 3 or 4 days after you've pitched, provided you've had a healthy pitch. From there, we go on to the stationary phase or conditioning phase. So this is from sort of 3, 4, 5 days through to basically when you either rack your beer into another vessel or you go to bottle or something like that. So at this point, the yeast sort of fermentation is all but finished or visible fermentation. So you're not seeing much of a gravity drop. Everything's kind of calmed down. There's no CO2 bubbling out anymore, maybe just a few bubbles. But at this point, the yeast, while it's still in suspension and after it's dropped out to the bottom, it gets to work reabsorbing a lot of the flavors that are associated with sort of green beer. So acetaldehyde, diacetyl, starts reabsorbing those and cleaning up the beer. So this is a phase that we really don't want to skip because it's really important for getting nice, clean flavor profile at the end. We start to see yeast drop out to the bottom, so flocculate. And usually at this stage, a lot of brewers will do what's called a diacetyl rise. So they'll let the fermentation go up by a couple of degrees just to help sort of speed this up and assist the yeast with their absorption of those kind of nasty, undesirable flavors.
So if a homebrewer was to skip that, I suppose the key point here is that the yeast is able to clean up your beer because it's still in the vessel, right?
Yeah.
So if you say like chilled it or racked it off of the yeast,
too early.
Too early. This can happen in commercial brewery too. Once that beer is off of that yeast cake, the yeast isn't able to clean it up. So if you've got something like diacetyl or other off flavors, it's kind of hard to go back in time at that point, isn't it?
Yeah.
Like when you don't want to skip that step, as in let your yeast finish, let it drop out into the bottom of the tank, and let that beer rest on there. Because the polishing is already starting to happen in the tank.
That's right.
Nice.
Yeah, cool. So that's kind of the sort of lowdown on I guess the fermentation process in a beer anyway. Blank slide. Cool. Sweet. So now we're going to mastering your yeast. So some ways that you can work to kind of really harness the power of these fantastic microbes to make the best brew that you can.
Yeah, so hey, cool steps. Those 3 stages there, really, really nice, and like a lot going on there for just a little bit of slop that you're chucking into your brew. It's awesome to zoom in on that a bit better. So yeah, let's jump into pitch rates next. So pitch rates, one of the most important variables in determining successful and consistent fermentations. So when we say pitch rates, we mean that's the number of yeast cells added in proportion to your brew volume and starting gravity. So that's usually expressed in a number of million cells per mil per degree Plato. So I assume most folks will be measuring gravity in specific gravity, 1050, 1060. Plato is just divide that by 4, so 1060 would be 15 Plato. And so there's a good reason why we want to hit a good target rate, pitch rate, and why it matters. So as we can see on this slide, underpitching can bring up off flavor compounds like diacetyl, can increase the lighter fusel alcohols, so those boozy tasting or boozy smelling lighter alcohols, increase in ester formation, which might be something you want to do in a sort of controlled manner. But if you overdo that with your underpitching, you can get excessive ester formation. Volatile sulfur compounds, higher terminal gravities, and stuck fermentation. So the yeast just kind of conks out before it's even done the job. So we've got lower alcohol and thicker, sweeter beer. And then an increased chance of infection because, in those crucial early stages of fermentation, we're wanting our introduced yeast culture to be the dominant that grows its population and completes fermentation. If you're underpitching, there's a risk that foreign microbes that may have contaminated kind of get ahead before your yeast and cause an infection. The other one on the flip side is overpitching. So very low ester production, very fast ferments. So if you're kind of charging through it too quick, your pH can drop too rapidly, and that can kind of shock the yeast. Thin or lacking body and mouthfeel, autolysis, which is kind of yeasty profile, and that's basically yeast cannibalism. If you didn't already know, it's how Marmite's made. So not a profile you want to have into your brew. But when there's so much yeast and not enough food or wort to go around, they can start to munch on each other. And with that as well, poor head retention. So as a general rule, inconsistent pitching is going to equal inconsistent beer, and vice versa. If you can try and be somewhat precise in your pitching methods, and you're trying to replicate that awesome brew you did last time as part of your winning recipe, your yeast pitch rates are going to be part of that. So what pitch rate should I be using? Well, these are the recommended pitch rates that we use here at Froth Technologies and that we recommend to commercial brewers. These are kind of the industry standard best practice pitch rates. And this is backed up by science, backed up by research. And so I suppose this pitch rate is, these pitch rates, you've got lower gravity ale, higher gravity ale, and then lower gravity lager there. This is trying to hit that sweet spot between under pitching and over pitching, where the risks of off flavors and infection are reduced, and the production of beneficial flavor compounds and good fermentation performance are achieved. So yeah, you know, not too much, not too little, not too little. This is the sweet spot here. So this is that formula you can see there. We mentioned earlier. So in a lower gravity ale up to 1060 gravity, 0.75 million cells per mil per degree Plato. So we've got a video here where we can kind of, there's a time lapse with a few different fermentations of the same wort with different pitch rates. So it's a good way to sort of visualize there in glass carboys how that impacts the brew performance. Here we go. So this is from our mates over in the US, Imperial Yeast. They share the same recommended pitch rates as us. There is a bit of variance out there, but we've, yeah, when it comes to recommending the best pitch rate, we've gone for
the best.
The best, you know, why would we recommend anything less? Cool. So, yeah, we can assume that. Cool, so we've got 4 different vessels of wort, 4 different pitch rates. The top one there, 200 billion cells. That's, yeah, pretty bang on to our recommended pitch rate for a lager of this gravity. Sorry, yeah, nail of this gravity. This one's 1059 starting gravity. And then we've got a, yeah, 0.54, 0.36, and a 0.18. So let's see what happens. And these look to be, yeah, 5 gallons, so 19 liters. Typical sort of homebrew volume. Here we go. Cool. So on the far left, we've got the recommended pitch rate, 200 billion. Obviously, that's kicking off straight away. I'll just hit pause there. That one's, yeah, we can see definitely a certain haziness in the wort as the yeast population is going through that lag phase and growing its population. And the krausen is creating that big tall foam on top. It's even puking out the top already. We're at the 9-hour mark there. And yeah, the 150 and 100 billion are sort of following close behind. Let's continue. Yeah, so they're playing catch up now, and that 50 billion is still just sort of catching up. They're all sort of puking out their airlocks into their respective, what are those little Erlenmeyer flasks? And we're at the 18-hour mark now, 24-hour mark. So they're all looking kind of similar at this point as they're at peak fermentation, but now we're starting to see at the sort of 1 hour, 1 day, 16-hour mark that the 200 billion on the far left is, you can see it's starting to finish up its fermentation. We're starting to see flocculation, and the yeast is starting to drop out and starting to clean up, while the others are still sort of just chugging along. So we can assume for sure that, like, the one on the far left there is probably chewed through a good amount of the gravity points by now, and then the 50 billion on the right is definitely still just sort of chugging along through them. And then, yeah, we're seeing that 200 billion really dropping out now and cleaning up those off flavor compounds and really polishing up the beer in there. So yeah, cool little visualization that we like to share, because it's yeah, not something we would usually maybe do at home, but it's yeah, cool to see it go down like that. Right on. I'll jump out there. Oh, back in here.
So yeah, and you'll note that as the gravity goes up, so if L is over 1060, the amount of yeast per mil per degree Plato increases as well. And that's basically because as the environment contains more sugar, the yeast need more troops to attack it in a healthy way. And with that pitch rate for lagers, that's a recommended rate for cold pitching of lagers. So sort of below 14 degrees. Some people do pitch lagers warm, and that is a way to sort of lessen the amount of yeast that you need. So they pitch it warm, wait 15 to sort of 24 hours, and then drop to lagering temps. And that just helps the yeast population grow. Yeah, so just a note on that.
Nice. What do we got next? Other factors.
Cool. So yeah, outside of pitch rate, a lot of other key factors that will determine a healthy fermentation. So one of them is nutrient composition. So for most all grain worts, all the macronutrients you need are going to be present within the wort by virtue of the mechanism of wort production. So that's really good. We don't have to worry too much about that. One thing to note, though, is that, and this is a bit of a hot topic at the moment, is with hazies, because they generally don't have they're not 100% malt in the grist. A lot of the time, you've got other adjuncts like oats and wheat and things like that in there. Those other adjuncts don't contain the same amount of one essential nutrient, which is free amino nitrogen. And so that can lead to hazies, particularly strong alcohol hazies, getting stuck fermentations, because one of the key building blocks of that yeast need to grow their population is missing. So yeah, just a bit of a note there on that. Adding, you can obviously get a lot of different yeast nutrients out there. I'm not sure if there's anything available in the homebrew market containing specifically high levels of free amino nitrogen.
White Labs, Cervomyces, organic nitrogen.
Okay, Cervomyces from White Labs apparently. Yeah, that is what it's called. A lot of the other ones may not contain that, but will contain a lot of the micronutrients, so like vitamins and minerals that will help yeast along as well. One that is kind of easier to control potentially is oxygenation. So this is a massive factor in really solidifying a strong lag phase and developmental stage for your yeast after you've added it to your fermenter. So yeast require oxygen for the buildup of lipids and sterols and fatty acids that they need to grow. And yeah, it's a super big determinant for a healthy and active ferment. So most brews, brews kind of up to 1060, need somewhere from 8 to 15 parts per million of oxygen. I know that's very difficult for home brewers to measure. A lot of commercial brewers don't have a dissolved oxygen meter, but as a guide, basically if you shook your wort to the most that you could, the most saturation of oxygen you can get is without sort of direct O2 input is about 8 parts per million. So just a note there that you're never going to overshake your home brew before adding your yeast. In fact, the more you do, the better it's going to be.
And some folks use what are they, like aquarium pumps with the wee diffusion stone, a bit less elbow grease way to sort of introduce that aeration, the oxygenation. So crucial after you've boiled your wort, because all that oxygen is sort of getting scrubbed out. Other ways, I've heard of some homebrewers getting like little oxygen bottles and bubbling those in through a stone for even more efficient. Yep.
And obviously we only want to add oxygen at the beginning of fermentation. because adding it sort of at the back end, that's something we want to avoid, because that will again cause off flavors and basically cause the beer to spoil prematurely. The one exception to that, which we've seen on some occasions, is high gravity beers, really high gravity beers over sort of 12%, which can benefit from a second oxygen introduction at the 24-hour mark, just to help that yeast get through a really sort of boozy, hostile environment. So temperature is the other one. I've mentioned it a little bit before, but yeah, so pitching cold. So for lagers, you would have seen that pitch rate requires more yeast. The colder you go, the more yeast you're going to need, basically. If you've got a healthy pitch rate, so something up around the one we recommend, you should be able to pitch at just below or at your desired ferment temperature and be good as gold. You shouldn't need to pitch warm. But yeah, I've already mentioned the pitching warm thing for lagers. I won't go over that again, but just, yeah, temperature and temperature control will go a long way to improving your homebrew if you're not already doing that. Another factor is, yeah, what kind of yeast profile you are after with your brew. So there are ways you can manipulate the outcome, your flavor outcome, by how you treat the yeast. So you can intentionally underpitch. I know a lot of brewers do this for things like Hefeweizens when they're trying to really accentuate those banana characters. Underpitching will heighten those esters. So you can sort of work with that in a controlled manner to stress the yeast a little bit. But again, you want to sort of take it in baby steps. So you don't want to cut your pitch rate down by half and then have a failed homebrew. But yeah, you can underpitch to accentuate esters, and you can add more yeast to get a cleaner profile. So just being aware of that. And yeah, so downstream application or reuse. So this is just kind of a consideration around, yeah, harvesting your yeast. Some beers you won't want to harvest your yeast out of. Those beers would traditionally be those over sort of 6.5–7%. We don't recommend harvesting yeast out of beers of that strength, purely because the level of ethanol in there can be toxic to the yeast and start to sort of break down the vitality and viability of the population. And another common one is really heavily hopped beers. There are ways around that, though, which we'll speak to a bit later on. Yeah, so those are some other factors on your yeast and fermentation. Cool. So we'll go to the next slide. Cool. Yeah. Growing yeast at home. Oh, cool. This is me again. Sweet. Awesome. Yeah. So, yeah, as we mentioned, there is a bit of variance in the pitch, the amount of yeast you'll get when you buy a homebrew pitch. So I guess just, yeah, being aware of that and making note of sort of what you have can help you in figuring out what pitch rate you're actually using. And one way that a lot of people deal with not having enough yeast in a homebrew pitch is by growing it up further through a starter. Which is really good practice in a lot of ways. It's going to revitalize your yeast population. If it is slightly old, it's going to get the yeast nice and active and ready for fermentation, and it's going to grow your population, hopefully to levels that you desire. Some key factors are, yeah, sanitation, like we mentioned with, you know, a small population of yeast, leaving room for other microbes to invade. The same thing occurs with a yeast starter. So really paying attention to your hygiene, cleaning and sanitizing. And usually we're looking at boiling your wort. That would definitely be our minimum recommended practice, your starter wort, boiling that and then cooling it. Yeah, so that's a bit on sanitation. I guess I'll quickly speak to sort of the difference between sanitation and sterilization as well. So sterilization is, you can't achieve that through a standard boil. That's something that you need to do basically under pressure at higher temperatures than can be achieved at atmospheric. So yeah, Simon mentioned before, we get our wort up to 121 degrees, 15 PSI, and you hold it there for 15 minutes. That's a process used by many labs for sterilizing implements and tools. It's called autoclaving. And it's kind of the industry standard for achieving sterility. That's the ideal. You can achieve that at home if you have a pressure cooker. But other than that, just really paying attention to your sanitation and using good practice is going to really help you.
Sand.
Yep, Star Sand's always a good one. Yeah, alcohol, ethanol. Yeah, high proof booze is good.
Yeah, I've seen people using meths because apparently in New Zealand it doesn't have the methanol in it. It's
Right.
just got a bittering agent, so you can buy just meths from the supermarket and use that in a spray bottle, and it's not going to be bad for you.
Cool. Yeah. So the other factor is knowing how much you're growing. And this is very difficult without sort of having a microscope or a basic lab set up at home. Luckily, there are a lot of calculators online, yeast pitch calculators. So I would recommend going and Googling some of those, Brewer's Friend or Mr. Multi. And yeah, they let you kind of input a few other factors as well, such as how agitated the yeast the slurry is going to be, which will help you figure out how many starter steps you need to get your desired pitch rate. Yeah, and so some of the keys for effective population growth, as I mentioned with the fermentation, oxygenation. O2 is a big factor in growing yeast population. So when we're growing a starter, we want to keep a fermentation in an aerobic environment, so fully saturated with air as much as possible. And that will basically keep it in the lag phase we talked about earlier and stop it from getting to the stage where it's producing ethanol at a high level. And we want to do this so that it focuses on growing healthy yeast cells and not eating the sugars and fermenting essentially. So yeah, one of the best, I remember when I was home brewing, I used to sort of I had a flask, which was great. Highly recommend you getting a 2-liter flask or something. Back then I only had just used to shake it up as frequently as I could. That's a good practice. It's better than leaving it sitting stationary. The best practice, if you are growing up starters at home, I'd highly recommend getting a stir bar and a stir plate. You can find them on AliExpress and some homebrew shops here, and having that at a really good spin, getting a lot of O2 introduced will really help you with growing healthy yeast starters.
We use them at the lab, in fact, Froth Technologies.
Yep, sure do.
Do a good job.
Yeah. So yeah, again, you can with your starter wort, you want to ideally have good nutrient composition in there. So adding additional nutrients is something I would encourage for starters. Just follow the dosage rates on whatever yeast nutrient you get. Ideally one, again, with high free amino nitrogen content, because that's a key building block. So yeah, just keep that. Free amino nitrogen, also called FAN, is sort of a real key for healthy yeast. And yeah, temperature. So you want to ideally grow your starters at a temperature similar to what it's going to be pitched into in the beer. The earlier you can start acclimatizing your yeast, the better. And yeah, that's just some key tips there.
Awesome.
Cool.
Sweet. So I'm gonna speak to storage and reuse next. Yeah, cool. I'm curious though. Let me just bring up so I can gallery view so I can see some more people. Oh no, it looks like a lot of folks have got their video off. I was gonna do a little crowdsourcing. I'm just curious if yeah, folks out there, give us a wave if you've used dry yeast before. Yeah, here we go. Cool. How about, have you used liquid yeast before, like white yeast or white labs? Cool. Have you ever cropped or saved or harvested some of your yeast slurry from a previous brew and then used it for another brew? Oh yeah, a few hands there too. And is anybody sort of like, I suppose, banking that, like keeping jars in the fridge and growing up starters? Is Anyone grown a starter before, like Ryan just described? Feeding it wort, giving it a shake. Cool. That's cool. Just doing a little crowdsourcing on people who've used liquid yeast before and if they've cropped it before. Cool. So
make sure you guys allow a bit of time to tell us about your products and everything, because I have no idea the products that you guys sell and where to buy them and stuff like that. So allow yourself a little bit of time for that.
Yeah, cool. We've got a little bit of time for that at the end.
Okay, cool. All good, mate.
Update on that one. Thank you.
So what's that? You're filtering out the lazy bastards here.
Right on. So yeah, harvesting and repitching. Yeah, cropping and reusing. So when it comes to cropping your yeast after it's had a first go at fermenting your wort, it can be a good idea for us to harvest that reasonably healthy slurry and give it another go and another brew. Obvious benefit there is if you've already bought that first pitch, you can spread that cost across a number of brews if you can harvest and repitch it. The other factor is that you can actually see enhanced performance from your yeast. Like it's come from a yeast lab when you've got it. It's had to get to you. It's maybe experienced some temperature fluctuation from the homebrew store to the shipping to your fridge. So actually it's like sort of second or third generation that the yeast is at its peak performance. It's got acclimatized to your brewing environment. It's got acclimatized to wort and booze and hops. And so if you're able to crop and repitch it, you're actually getting it to its peak performance around that third generation. And then off the other side of there, it starts to sort of deteriorate and start to sort of mutate and gets to a point where we can't just keep using it forever and ever. We need to get a fresh pitch. Flocculation and flavor compound production also enhanced in those second and third generations. Obviously with that comes some risk, like if you're opening a yeast packet and just tipping it in, that's a bit less risky than say cropping some out of your vessel and storing it. But certainly not risks that can't be mitigated and managed.
Sanitation is key.
Sanitation coming up there once again, something we're all already familiar with when it comes to brewing. Pitch rate inconsistency. So like I suppose the risk there is like if you're not able to sort of grasp how much yeast you're cropping and how much you're pitching into the next one, it can be a bit inconsistent, unpredictable. That may or may not be of concern to you. Low viability,
so that can come from like harvesting out of a really strong beer, so a beer sort of above 7% alcohol. Can just lead to sort of puts the yeast under additional stress through toxicity. Basically, it's not to say you can't do it. A lot of commercial breweries mainly brew beers over 7%, so they have no choice. But I guess it's just the longer the more generations you would have yeast in higher gravity beers, the higher the chance of a low viability coming out.
Yeah, likewise, if you say weren't storing your yeast responsibly or in good condition, you would start to see low viability there too. Like if it wasn't in the fridge or something like that.
And just in case anyone doesn't know, so when we're talking about yeast viability, we're talking about the percentage of cells that are alive and dead. So that's usually measured under a microscope by staining the cells. The dead ones uptake the dye, and we can see how many are alive and dead.
And so the freshest of the fresh yeast that's coming out of our tanks into jugs is typically like 99% viability. So 99% of the cells are alive. And with the decay of time, just like our own bodies are slowly aging, as does yeast cells, and so that viability drops over time in percentage. Yeah, key considerations around that. Yeah, once again, hygiene, sanitation. So just like anything that is going to touch your yeast slurry needs to be clean. That includes your hands. That includes spoon. So yeah, a good homebrew sanitizer once your things are clean. Soaking them in sanitizer like Star San.
Or ideally, boiling like glass vessels and metal things. If you can boil them in water for 10 minutes at least, that would be the probably best achievable practice at a homebrew level.
Yeah, just that time factor where if your yeast is going to be in there for more than, for a little bit of time, you want it to be as clean as possible.
Another good just consideration is when you are harvesting yeast or sort of looking at handling yeast, try and minimize the amount of draft. So ideally do it with like doors closed and things like that. You don't want to open to the air because that's where yeast and other microbes like to hang out. So
yeah. And so thinking about your storage time and storage method. So like, am I gonna use this slurry in the near future? You may not have a brew day planned, but if you went to the effort of saving cropping that slurry, it's cool to be able to use it within a reasonable amount of time. Like, I mean, ideally within a few weeks, if you're just going to pitch that straight slurry, you can certainly stretch it a little bit further. Otherwise, if you're able to make a yeast starter and wake it up again, you can whack a dab of that yeast slurry into some fresh 1040 wort and give it that aeration or shaking or stirring, whatever you're able to do 24 hours ahead of time to bring that population back to life. And that's not so much like, say, you're like a whole jar of slurry, because when you make beer, you end up with more yeast than you need for another brew. It might be, say, 2 or 3 brews worth of yeast is how much you end up with from your one previous brew. So like if you're doing a starter, you're kind of whacking in like a good tablespoon of slurry rather than like a whole jam jar.
That would be for like a 2 liter starter. If you did like 1 or 2 tablespoons of good slurry, you should be all good. Just
keep that in mind, because if you were, say, to add like a whole wheat jar of slurry into 2 liters, that ratio of that pitch rate essentially of yeast going into that wort is going to be too high, and so you're not actually going to grow much yeast, because the yeast is going to immediately recognize that there's not much food to go around. When if it's just those 1 or 2 tablespoons, it goes, okay, nice, there's heaps of food here, let's grow our population. Great. And so you get a whole lot of freshly grown healthy active yeast. So just keep that in mind.
And I'm just I guess clarifying that we're talking about a couple of tablespoons of like thick slurry.
Yeah.
And another clarification thing, Simon mentioned 1040 gravity wort. You really don't need to go above that. That is going to be between 1036 and 1040 is around your optimal kind of gravity for a starter. Beyond that, you're not going to get much better cell density. Below that, you're not going to hit your target. So hitting those levels will serve you well.
Yeah.
Yeah, cool. Sweet. All right. Let's go. Cool. Sweet. Yeah.
Yeah, so this diagram here just sort of, well, it's, as you can see, it's showing a conical fermenter. And what we're demonstrating here is how at the bottom you can see the darker dead yeast that drops out much quicker, the true as well. Let's do a little show of hands again. Anyone using a conical fermenter? That could be a stainless one or a Firmzilla. Or no, not much in that. Oh, Paul's got one. Yeah. And I suppose most people would, typically be using like a fermenter bucket, barrel with a flat bottom. Is that right? Yep. Cool. Yeah. So either vessels are still gonna see this layering. And yeah, the middle part of that layering is where the healthiest yeast is going to lie. Typically sort of in the later stages of fermentation or like crash cooling, that poor flocculating yeast is kind of a fluffy, fuzzy layer above the thicker yeast cake. So if you say like racking off to secondary and you're draining off as much work or as much finished beer as you can, you know, there might be a little bit of fluffy, murky beer at the bottom that comes through. But yeah, that top layer of yeast at the bottom of your fermenter is what you want to aim for. So if you're kind of scooping out with your clean spoon into a jar, maybe that just means, you know, not digging right to the bottom where your hop particles probably are, the deadest of the yeast, but just sort of trying to skim the top off there where it's nice and that nice beige, creamy color there.
Creamy beige.
Yeah. And yeah, this is just a little mention on the types of vessels. As we mentioned, like a glass jar is really easy to get your hands on, easy to boil for 10 minutes to get it super clean.
Yeah, it doesn't have dead spots where microbes can hang around generally. They're pretty good for a homebrew sort of yeast storage vessel.
Yeah, and just keeping in mind that it's still an active living thing, so like things can get kind of pressurized. You don't even need to like crank your jar lid on super tight. You can just have it like slightly loose to allow for venting, or you can burp it intermittently, or just wrap the whole top in tin foil, because microbes can fly through, the airborne, but they can't crawl. They can't sort of get up and under. I mean, we use tin foil on our flasks and things all the time for that reason. Sweet. We're getting towards the end now. This is hazy IPA haze retention.
Yeah, so I guess just before we get too far into that as well, if you're brewing a hazy and you want to harvest your yeast, what you don't want to do is bring a whole lot of hops with it. Hops aren't great for yeast and yeast storage. So what you can do is sterilize or sanitize some water by boiling it in a jar, allow that to cool down. And if you've harvested some slurry that is contaminated with hops because of it's all in the same vessel, it's likely to happen. Take that hoppy, yeasty slurry and add it into a vessel of sanitized water once it's cool. And what you can do is shake that around really aggressively. The idea there is to break up the flocks of yeast and then let it sit. The best vessel for this is something tall and narrow. And the idea here is that we're trying to sort of encourage that separation that Simon showed in that diagram before of the dead yeast and the trub, and then the healthy yeast. So what will happen is after you've kind of added your yeast to your water, shaken it around, let it sit, the first layer, or the bottom layer, the first stuff that drops out is going to be mostly hops and dead yeast. The milky kind of milky watery liquid, that's the good stuff you want to get. So you can, once you see that first layer sort of drop out, it doesn't take too long, maybe 10 minutes, you can then decant the milky liquid into another sanitized vessel, and that will be your healthy yeast. So just a note on how to recommend a practice for harvesting yeast from a really hoppy brew. But let's get into some haze retention stuff. So yeah, hazies and yeast. So it's often assumed that the haze in a hazy is actually yeast itself hanging out. And this certainly can be the case for some commercial brews and a lot of homebrew. You'll see a thick slug of yeast sometimes at the bottom of your beer. However, this isn't necessarily desirable. The real way that we want to generate haze in a hazy is through protein additions and biotransformation. So with keeping that in mind, one thing to note is that yeast health is really important for this. You can go to all the effort of building a really nice grist with heaps of adjuncts to promote haze like oats and wheat. But But if you are underpitching your yeast, or your yeast is stressed out or doesn't have enough nutrition, what it will do is it will actually start scavenging for nutrients. And where it will find those is in the protein that makes up your haze. So the yeast can effectively eat the haze out of hazies if it's not happy. And we've seen this in commercial beers, where they'll, at the time of packaging, the beer is hazy, really orange juice looking. And then by the time it pours, it's significantly more clear. So the things you can do to help combat this and promote haze retention is, a really healthy pitch rate, lots of O2 when you're pitching your yeast, and ideally additional free amino nitrogen, that key sort of nutrient, because of the lack of it in a heavily adjunct grist. So that's sort of I guess just a note there on haze retention, because we get a lot of questions about that a lot of the time. So healthy yeast equals happy haze. The other sort of thing to consider, how do I move that clip? With hazies is a thing called hop creep. So traditionally when we add hops to a brew, it goes in the boil. And what that does is that will neutralize the enzymes that naturally hang out on hops. So there are enzymes on hops. They're amylolytic enzymes. So they're starch degrading. They break down starches into sugars. When we add hops during a fermentation, particularly like with hazies, those enzymes end up in our brew, and they'll break down previously unfermentable dextrins into available sugars. And that will lead to additional fermentation, additional attenuation, so more alcohol production and more sugars consumed. On a homebrew level, it's not necessarily a big issue, but it's something to be aware of if you're trying to hit a target ABV. For commercial breweries, it is a big issue because they are often sort of already have labels printed with a set alcohol by volume percentage, and when their beer attenuates more than they had expected, that means they have to then adjust, take sort of drastic measures. So yeah, some strains can actually show like 5 to 10% more attenuation based on hop creep, so the heavily dry hopped beers during ferment. Unfortunately, there's no real great way to kind of manage this. It comes down to kind of exposure time of hops and the amount of yeast and the amount of hops in a beer. So that's why hazies is such an issue. But you can kind of, if you're brewing a hazy regularly, the best way to go if you're trying to hit an ABV is just to monitor your fermentation really regularly. And if you want to bring back that alcohol content, adjusting your mash is probably the best way to go, because then the enzymes have to work harder to break down those starches. There's also a lot of evidence that, dry hopping exposure times, you don't actually need to leave them in there for a super long time. So they're shown to be not a heck of a lot more flavor or aroma production based on hopping from a 6-hour exposure through to 4 days. So maybe using like a hop bag or a hop spider or something inside of your fermenter where you can dose it and then remove the hops, that might help to sort of mitigate some hop creep. But yeah, it's just something to be aware of, just another little thing about hazies.
Do you know if that enzyme can be denatured at all?
Well,
is it heat sensitive?
Yeah, it is, because normally in a boil,
it gets
but
denatured.
because you're adding it to a
dry hop, you don't want to boil your dry hops because
no,
it tastes like veggies or something.
Yeah. So you can heat treat your hops if you want it as well to a certain level, 60 degrees. But yeah, it's a bit of faffing around.
Yeah, I wondered about vacuum heat treating. You know how the boil temperature comes down. Super interesting.
Yeah. Anyway,
hop creeps.
Ham
creeps.
Cool.
Oh shit! There's us again.
All right.
Cool. That brings us to the end of our talk here today, and yeah, we've got homebrew yeast. I can see we've got maybe 13 questions in the chat, so we'll get to those next. But yeah, homebrew yeast. So as we've described this evening, with Froth Technologies has come into existence to initially at least produce commercial pitching quantities of yeast for breweries, and we're now supplying to 40 different breweries around New Zealand. And yeah, of course, we don't want to forget our roots and the home brewers like yourselves. So yeah, we've definitely got a strong intention to be able to offer homebrew pitches as well. That's something we've been working on. Turns out it's not as simple as just like put the yeast in a smaller bottle. It's definitely a bit more tricky than that. We've wanted to go for like the most sustainable packaging option we can, something that's recyclable or even reusable. So we've trialed a number of different packaging options there, so you can sort of use our yeast and then chuck in the recycling bin, or crop your own yeast and chuck it back in the bottle. But you know, that's important to us and to our business.
Yeah, and the other piece is finding something that's going to be practical for homebrewers to use. I guess one of the things that we've discovered and we've been trying to mitigate is the fact that yeast slurry contains a lot of carbon dioxide, which when you're storing it in a small vessel with not much headspace can lead to a good amount of pressure. So we've developed some processes around that, which seem to be so far reducing the amount of pressure buildup, which is great. It's taken a lot of figuring out, a lot of different approaches, but yeah, we're getting pretty close.
And we put a homebrew survey out. When was that? Earlier this year.
Or last year.
Surveyed a bunch of homebrewers because as we shared a bit earlier, there's different pitch rates that you can go for when it comes to brewing. If you've played around with yeast calculators and online resources before, you might have seen that the recipe or the calculator is telling you that you need like two packs of liquid yeast, or you need to make a starter. What we're aiming for is basically one pack, which has got 2 packs worth of yeast inside of it. So you don't need to make a starter. You can pitch it straight in, and it's kind of enough to ferment like 19 liters of sort of 1060 wort, or like 23 liters of sort of 1045 or something like that. Like, it's got good wiggle room.
That's with hitting those best practice pitch rates, which is what we encourage to our commercial brewers and what we want to help home brewers do as well.
So you could still grow a starter if you're, say, wanting to make a 10% imperial stout or whatever. But yeah, our idea there was like, why make a homebrew pitch that is like about halfway as much as you need, when we're seeing some inspiring yeast labs out there in different parts of the world that are doing those direct pitch options. So that's what we've been working towards. We're getting pretty close now, and well, I'd say towards later this year.
Yeah, we're hoping to have it sort of on the market for summer. So which would be really cool, because that's often when a lot of brewing and a lot of drinking gets done. So we certainly want to try and get there in time for that. And
that's not something we'll sell. We intend on selling directly. We don't want to sort of cut the lunch of all the awesome homebrew stores out there that you'll be familiar with. Naturally, just about all of them, I think, in the country have been in touch at some point since we started out, just registering their interest and like, hey, we'd love to support you. So yeah, we're looking forward to sort of getting those out there and into the fridges of homebrew stores around the country. And
and so those homebrew yeasts will be the same yeast that strains that we're currently offering to our commercial clients, which we have 8 of. So they are kind of industry standard strains. So we've got an American ale, we've got a hazy yeast, we've got a couple of English ale styles, we've got a Belgian wit, a German lager, a Czech pilsner, And I think that's all we've got at the moment. We're hoping to bring more strains on at some point in the future, but just have to keep juggling what can fit through our production facility at the moment. So yeah, and we're also working on an R&D project with Callahan Innovation, which is our New Zealand wild yeast project. So a couple of years ago, we went around the country to a few different spots right up in Northland, Hawke's Bay, and the west coast of the South Island. And we took some samples from native trees and plants, so flowers and berries, because we wanted to see what awesome yeast were on there, with the idea of finding something that's uniquely Kiwi that we can put into brews. And that R&D project is still ongoing. We found nearly 400 different isolates, and we've narrowed that pool down to around 100, which seem to be able to withstand beer fermentation conditions. So yeah, that's still a work in progress, but we're hoping to find something super cool from that. So just a bit of an update there as well. Yeah,
cool. So we've probably taken enough of your time so far.
That was awesome. Thank you. Can you just stop your screen share, Simon?
Yeah.
Very awesome. Thank you so much. That was very, very cool indeed. And lots of questions, as you say.
Yeah, we'll try to chop through them quickly so we don't keep people
good.
long. But
good.
Cool.
Right, go on then. You read them out. Off you goes.
All right. Are we utilizing a tilt or something else for gravity measurement? So yeah, we covered that earlier. We're using that brew monitor device, which gives us real-time fermentation monitoring on 7 different parameters. So essentially a souped-up tilt. Yes.
Well, Paul's obviously played around with some Kvike yeast, mentioning that can fully attenuate in the same time as lag phase for some yeast. Yeah, totally right. It's incredible stuff, that. And yeah, once again, naturally selecting for those fast and warm fermentations there in Scandinavia. Very cool. Clive asked, if you can't pitch at fermentation temperature, what would be preferable? Pitch a few degrees too high or a few degrees too low? Good question.
So that would, I guess, depend on how confident you are that you've got a solid pitch. If you have got a really healthy pitch going in, I would say pitch at lower temp, so pitch slightly below your desired fermentation temp. If you are thinking you might not have enough yeast, go on the warm side. So it sort of depends on how confident you are in your ability to measure that.
Mm-hmm.
Very good, thank you, because I get conflicting advice there. Yeah, I'm never really, all right, interesting, thanks.
Yep.
Yeah.
Just on that, I mean, quite often if we're making a lager, we can't get the wort down to lager fermentation temperatures. So do you first bring the wort down to those cold temps and then pitch, or can you just pitch and then just chuck in the fridge? And
is that due to your your tap water temperature?
Correct.
Yeah.
Same kind of principle as with the prior question. So if you've got so lagers generally for a cold pitch need twice as much yeast to get it as an ale. So if you're working with an ale amount of yeast, so or just like a single or a couple of homebrew packs, I would say pitching warm is what you actually probably want to do, just to get that yeast to grow the population, and then, as you say, chuck it in the fridge and cool it down.
Like 17, 18.
Yeah, 17 or 18 degrees should be fine.
Is that what you can hit with your setup?
well, at this time of year, no worries. I can hit that easy. But
But
in summertime, sometimes it's 20 degrees sometimes.
Okay.
Yeah,
Sometimes I've heard of homebrewers sort of like having a spare fermenter in a fridge as like some extra, just to get it down that a little bit further.
I guess it's the risk of infection, right, or contamination as you're cooling. So there's like a, would you rather have your wort sitting around for another hour or two while the fridge takes it those last 3 degrees, or whatever it might be, or would you rather pitch the yeast in there and cool? Go on then. What's the A or B?
Pitch, yeah.
Yeah,
pitch it.
so I would say if you can get if you're going to be adding a really strong pitch, waiting an extra hour to drop the temps shouldn't be an issue. But again, if you're working with maybe not a full lager pitch amount, which is again double the amount you need for an ale, I would say get the yeast in there early, keep it up at those warmer temps for say 12 to 24 hours to let that population grow, and then chuck it in the fridge to bring it down those extra 5, 6, 7 degrees or whatever.
That same advice apply for an ale as well as a lager?
So yeah, essentially if you're thinking that you're going to be under pitching, pitching it warmer is going to help that yeast population grow more rapidly. However, it's not going to be a cure for under pitching. So you can't just add half the amount of yeast and put it in warm and everything will be sweet. You still really want to try and hit that good pitch rate, but warmer temps will help mitigate that. So less yeast, slightly warmer. More yeast, you can go slightly colder.
And we're talking like sort of a few degrees of adjustment here, not like 28, bring it down to 20 sort of deal.
I mean, it's that always that sort of 2 to 3 degrees of hit that pitch temperature straight out of the after cooling,
That's the one.
Sweet as. Kevin has asked, can you talk a little more about cold crashing and fermentation? Sweet. Anything in particular about that, Kevin, or you just want us to riff? Might need to turn your mute off there. Oh, here we go.
Yeah, I'm not sure what you mean by cold crashing the fermentation.
Oh yeah, cool. Yeah, so that usually refers to like fermentation is complete, the yeast is dropped out in your tank, and we're sort of at the 10-day mark where it's cleaned itself up. In a commercial brewery, you'll set the tank to a colder temperature, crash cooling. At homebrew, folks, if you've got your fermenter in a fridge, you might set it to cool. I assume there's a few different ways.
Oh, so you're meaning like for clarifying the beer?
Yeah, chilling it down to 2 degrees.
Or colder. So crash cooling is just rapid drop of temperature is what we mean by that. So chucking it in a fridge and bringing it down to help clarify it out at once it's finished.
Oh, okay. Yeah, I thought you meant something else. Okay.
Yeah. Yep.
Sweet. What are the main precursors to yeast-driven off flavors besides temperature? Yeah, so I think we covered that a bit there with fermentation-driven. Yeah, under pitching, poor yeast health,
not enough oxygen.
Yeah.
So
poor nutrition.
Anything that causes yeast to feel stressed in its environment is going to make it sort of work harder, and it's basically going to sweat more, and it's going to sweat out those precursors. So the big ones are under pitching. That's probably the one of the most significant. Oxygenation. If you don't have enough O2 or aeration in there, your population isn't going to have what it needs to grow, and so it's going to start sort of again scavenging around for things and working hard. Going too warm on a ferment can cause stress as well, or big temperature fluctuations. So ideally, once we pitch our yeast, we want to not have it rise or cool too rapidly, because that can sort of shock it and just cause it a bit of stress. And then nutrition as well. So those would be the big ones that will cause fermentation driven.
Thanks for that. What are your thoughts on over-oxygenation?
At a homebrew level, you're going to really struggle to achieve that. If you are directly injecting pure oxygen, you can do that. But even at a really solid flow rate of oxygen, you're going to struggle to over-oxygenate. I did mention earlier in the talk, if you're aerating, so just shaking or somehow injecting air, not pure oxygen, into your work, the maximum saturation you're going to achieve is 8 parts per million, and that is kind of happy conditions for yeast.
Nice. Question here about non-malt ingredients. Adjunct as part of the grist, starting to be of concern.
So what is it?
For lower fan levels. So what percentage? It's kind of just like a sliding scale, you know, like the more barley you take out and you replace with oats, the less fan you're going to have, and then the higher gravity, that's you sort of exemplifying that stress. I know like New Zealand has pretty good quality malt as well. Base malt in particular is the highest fan content.
Yeah, fan levels are high. I just wondered sort of what percentage you sort of start working at before you start worrying about it. And what, do you have a target goal for fan levels in a beer?
Yeah, I mean, it's not something. I mean,
we
it's
have
easy
target
to determine because you'd have to get like your work analyzed. I mean,
we have really
is not-
high target fan level for our yeast propagations because we're just really wanting to push that population growth. I would say, in terms of percentage non-malt, I'd say you'd be able to get away with like probably 25-30% with that. Like, provided you're using a good base malt, it's a significant portion. You should be okay. Obviously, it's also in relation to those other factors like oxygenation and things like that as well.
Supporting your yeast health.
Yeah,
not a major one, but just something to think about.
Yeah, I don't think it's so much of an issue for home brewers because a lot of them aren't using pure, they're using more complex nutrients and things like that. When they do use it, they'll use, Y yeast nutrients or one of the more rounded Lallemon. They're not sort of just using, cheaper commercial sources.
Yeah. So you should be good, provided you're adding some kind of nutrient and monitoring those other conditions. You're doing the right things. Yeah.
Nice. Next question is, do you recommend using a 1050 unfermented hopped wort from a previous brew for a starter? Yeah, totally. So I mean, 1040 was the recommended baseline there. But if you're making wort on your previous batch and you want to set some aside, I've definitely seen that done before. You obviously just got to set it aside in a way that it's not going to start fermenting on its own.
So you'd want to be using it pretty rapidly after wort production. Unless you were sterilizing it.
Pressure cooking cans of wort, and so you've just got it on hand.
The other piece.
What would you say about, say, bottling it? And then bringing it out and boiling it, watering it down to 1040.
It's likely it's going to start fermenting unless you're able to like sterilize it.
Yeah.
Okay.
So
if you bottled it unfermented, even if you've sanitized your bottles and stuff,
put it in the fridge.
Putting it in the fridge will arrest it. You could
still probably going to start, but it's definitely going to start to build pressure, and it will be a mark as to whether it builds enough pressure to pop.
Okay. All right.
Yeah.
The other thing there on that question is around the hopped wort. So you wouldn't want to use a highly hopped wort. So sort of maximum kind of like 10 IBUs. Up to that level is actually a really good thing for yeast starters because it will prevent 10 IBUs will help inhibit the growth of spoilage organisms like lactobacillus, which is something I probably should have mentioned in my tips for starters, but I didn't. But a little bit of hops to around 10 IBUs is a good thing in starters, but above that you start to go in the other direction.
Thanks very much.
Great.
No worries.
Next question, at a homebrew level, do you have an opinion of harvest versus overbuild?
When you overbuild your starter and hold that over rather than actually harvest off the cake.
Yeah. We got asked that last.
It's another 50-50 call. I'm just curious where you guys sit on the fence.
No. So you're saying that you
could be on the fence.
You do a starter, you pitch in your yeast, but you grow.
Yeah, you overbuild maybe 30%
as you need. Right. Okay. Yeah, but more than you need, and then reserve that rather than cropping. I'd say that's better than going
Yeah.
to be better.
I think if you provided all your other conditions around sanitation and stuff are good and storage, I think it's probably a better call because you're not going to be harvesting slurry that contains a high percentage of trub or hops, and it hasn't been exposed to alcohol, which is going to have an impact on it. So yeah, particularly if you're planning on brewing like a high gravity beer or a really hoppy beer, I think diverting some of your starter off and saving it to then probably grow again in another starter is a really good practice.
And we even see some commercial breweries do that actually. Like some will pitch in their tank, do their fermentation, and then crop out the bottom. Others will pitch our yeast into like a smaller sort of propagation vessel.
So it's just run it as a small scale brink kind of thing.
Yeah, crop some out into their tank, but then leave some behind and top that up. And now we're at second generation, and it sort of hasn't been exposed to the.
Yeah, I found it's been fun as long as you let it run full cycles. You end up with like it starving. It's pretty sweet.
Yeah,
Totally.
That's a good good tip to include there. Reese is asking, where have you sourced your yeast? Yeah, so we're carrying a range of sort of industry standard strains. Like other yeast labs, they are the same strains under different names. So these strains originate from different breweries in different parts of the world. Our American ale yeast is thought to come from Sierra Nevada, and before that, British Columbia. What else we got? German lager from Weihenstephan. Our Czech Pilsen strain from Budvar in Czech Republic. So, these are strains that have lived in breweries for sometimes centuries. They've become domesticated there. They've developed the unique traits that we appreciate from them. And yeah, as you know, you can obtain these strains from all different parts of the world, in pure form from labs in different parts of the world. So we're essentially growing the same strains genetically as those industry favorites, but growing them here in New Zealand for the first time.
Yeah. So like for example, our American ale, which we call Buddy, goes by many other names. It goes by WLP 001. It goes by the name US05. It goes by the whatever Y Yeast's first American ale one is, like 1056, I think. Yeah. Same strains, different names. It's
Yeah. Are you sourcing from like originating yeast banks, or you're actually propagating off a commercial sample?
Yeah. So we start with the pure culture, and at our lab we have those stored in a cryogenic freezer at -80 degrees. So we've got our like mother culture there, sleeping in a deep frosty sleep, and not too often do we open the freezer. Only when we need to replenish like our agar slopes, which are more.
So how often do you go back to your original propagation source rather than slates?
Yeah, so it's we generally about once a year, which is probably being more like cautious than is necessarily required. We just want to make sure we're not getting any strange mutations or anything, which we've got a heap of checks and balances along the way for anyway. But we just like to we refresh our. We go from cryo stocks through to working stocks, which are agar slope, and then we will subculture. That will last for about 4 months with us, our in-house expiry, and then we subculture that onto another slope, and then one more. So we do basically 1 year's worth of slopes off one streak from a cryo vial.
Yeah.
So Dr. Ashley's not called you up for -80 storage there.
No, we did actually think about it though. We thought we should put our hands up, but I'm not sure what the risk of
fertility services.
Yeah.
Wants to get in touch. Got heaps of space in that freezer.
Yeah, we could end up with Ryan's children all over the country, which could be awful.
So you're going to cross contaminate the yeast.
That's right. Yeah, we got to be careful with that sort of stuff.
Special house strain. Yeah.
When you guys are doing propagation in your reactors, are you primarily using a anaerobic or aerobic process for that?
Aerobic.
Yeah.
So we use an air compressor. So we're using air, not O2 for the most part. And that air compressor goes through a like 3-stage filtration process. So there's 2 dryers, a pre-filter, and then a medical grade HEPA filter, and then another inline medical grade HEPA filter, just to make sure that it's sterile. So but we are constantly aerating. It's in surplus of like 30 liters a minute goes through our largest propagation tank, and that serves to keep it aerobic and also agitate. So we inject it from the bottom of the tank, so it keeps everything nice and homogenized and mixed up.
Doesn't make for good.
You're doing any dose nutrient control, or you're basically just pitching nutrients right at the start? Yeah, cool.
Nah, nutrient right at the start. We sort of don't have the
injection,
the tech, or the we just sort of hit it at the start of that particular stage, and then run it through.
Cool.
Yeah.
Can you touch a wee bit on the native Aotearoa yeast, which is that's going to be pretty cool if that comes off and you've got some cultures there, because that will be a true uniqueness like we have with hops. So
terroir. Yeah, we're pretty excited about that one. We've invested a good amount of time and definitely a lot of money in that one, especially for a young business like ours. We're hoping we'll be successful. Success for us would probably look like, at least like maybe 4 or 5 different usable strains. As Ryan mentioned, we started with 400 isolates. A lot of those are going to be duplicates. A lot of those, they've already sort of been partially selected for Saccharomyces, but they haven't been genetically identified yet. They haven't been through sensory yet, so there'll be a bunch in there that won't smell or taste any good. They have been through the sort of boot camp stage of our testing, where they've been able to ferment to 7% and 4 pH. So that's sort of promising early days.
We talked to Jamie from Cell Division with his propagations, the things he's done.
Cell Division.
We have spoken to him, but
they're not one of our customers yet.
He's not brewing at the moment. He took a sabbatical. He was supposed to be overseas.
He's supposed to be COVID,
and then COVID hit. So he packed up his brewery and left his job at the university for a year and a half to travel. And Rona had other ideas.
Okay.
Cool.
Yeah. Ideal.
But he's isolated like a homegrown sort of thing, and his parents have fruit orchards and things. So he's isolated stuff which is truly worthy and making really nice Belgian style beers out of. So be worth the chat.
Well, he's got his house strain like a lot of other people have. There's quite a few breweries in New Zealand that will have their wild house strain. I think what you guys are doing is pretty awesome. So you're just doing technical selection at the moment. You haven't gotten to sensory selection yet.
That's we've got one more stage of technical selection. So we're looking, the kind of process we've developed is looking ideally for Saccharomyces cerevisiae, so clean ale yeast. Whether or not we find that is kind of the next stage. So you're
not going for spawn. You're actually going for wild. Awesome.
Yeah, that's what we're looking for. The idea being that it's easier for a lot of breweries to utilize because a lot of them are without introducing wild cultures. However, we're not sure what we'll find. So that's the next stage, is sort of seeing which ones are likely to be Sac cerevisiae and which ones are sort of definitely wild. And from there, that will kind of change our subsequent approach, I guess.
How do you do isolation and selection with that? I mean, if you're collecting, like I presume in a wild context, and you're trying to pull out CV, what are you just doing? Like significant dilution and then just lots of random, picking off strains and seeing what's sort of,
more or less. Like there's initial sort of getting the isolates off of the wild samples, so like washing and enrichment,
banking,
banking the different isolates, number of which are going to be duplicates. And then it's what method we're using for those?
We're using rapid
optical density. Prior to that, we had plate selection.
Yeah.
So we've started, initially starting to select for Saccharomyces with antibiotics, and then agar plates with selective media, and then beyond that we sort of go to these state-of-the-art devices which are like optical density. So basically like a whole lot of little wells that are like 1 mil each, and so each little well in a grid is basically a whole lot of tiny fermenters, so you can conduct like many different fermentations at once, each one inoculated with a different yeast, and then you can chuck that whole rack of tiny fermenters into a device which shines light through each one, and can tell you basically how hazy it is, which tells you how many. It can determine how many the cell population that's growing in each one. So definitely the kind of toys we don't have at our lab, but that's why we partner with Callahan Innovation, because they have the know-how and the toys to do that kind of stuff, and we can sort of get like a rough plot initially. If something starts with high clarity and it's still got high clarity after 24 hours, it hasn't done much, and compared to something that's gone really hazy, we can tell that despite there being 7% alcohol and 4 pH, it's still growing a cell population, so it gets a big tick and goes to the next round for what.
And hopefully this hazy phase of beer will be a short-lived fad.
Well, yeah,
clear beer.
It doesn't seem to be going anywhere super fast, but we certainly love to encourage a greater diversity of beer styles.
And it starts with the home brewers.
Yeah.
What you guys are doing on that, so I didn't realize it was Saccharomyces. I mean, that's really cool.
Yeah.
We're definitely trying.
We will see what happens.
We might just waste a bunch of money, but no. So far, it's definitely going better than.
Great marketing brand story, even if you fail. I mean, sure. Yeah, I mean, it's a wicked thing to be able to do.
We just started with such a wide net that we're like, cool. We're going to have to hone it down each round to get to something that's usable in a brewery. But yeah, so far so good. Jump on the next question. Clive asked the best way to clean the magnetic flea. It is used in a stir plate, as I think boiling it will kill its magnetism. Bleach, pink powder.
Oh yeah, so that's the little stir bar.
Stir bar.
Yeah, stir bar is
Yeah. So yeah, I would say like giving it like a clean first of all with like PBW or whatever your cleaning solution is, and then ideally soaking it in some booze. The higher, like ideally like some high strength, either meths or some 40% vodka, but ideally up around 70% ethanol is going to be your best sanitation rate, and that will just you'll provided it's clean, you'll kill everything.
So you just need like a little bottle cap or some kind of lid or something, so you just
don't
need too much of that high proof, and then
I was always worried about it getting being unclean because I hadn't boiled it, but good. And harvesting yeast, so it's always a bit hit and miss with me, that harvesting yeast thing. Sometimes it was brilliant and other times not, but how much it's how much do you, so you get that nice creamy layer, how do you know, because it's just as you said before, you just don't know how many cells you're actually
getting. I actually should have, we did a thing a while ago for some commercial breweries around just the thickness of yeast slurry. But just to kind of, we had some sort of slurry at 1 billion cells per mil and some at 2 billion. It's a bit hard to describe verbally. There might be some sort of, I'm not sure, there might be some resources, some images online. I'm trying to recall, there is actually a metric of sort of like, if it's 50% solids or 50% slurry, I think that's around 2 billion cells per mil. Do you recall, Simon? I think so. I think if you're looking at sort of 50% slurry to wort or supernatant on top, that's around 2 billion cells per mil of the total mix. So in that case, you'd need 100 mils of that to hit a 200 billion pitch rate. But again, that's kind of like a loose guide.
It's just really hard. Hey? It's just hard to know at a homebrew level how many cells you got. All right. No,
totally, it is, and there's no really easy way around that, other than like I guess one way to go is sort of to to take some samples and maybe like as you're brewing, you know, keep a metric of like, cool, this one was that thick or that much percentage was solids when it has settled. I added that gave a good result or a bad one, and then tweak from there. But yeah, it is hard for homebrewers, absolutely. Yeah.
Question about the effect of lowering the temperature dry hopping on hop creep. I think it just prolongs the inevitable, doesn't it? Once those enzymes are in there.
Yeah, it would slow it, but it would
temperature.
still happen. There is some I've seen some advice around sort of actually having a warmer ferment with the idea of trying to increase the rate of hop creep so that it happens during the usual ferment as opposed to like in your bottle or something. But yeah, hop creep's a real tricky one. There's no quick solution for it, unfortunately. It's more something to kind of be aware of, and particularly if you were doing it like a hazy or a heavily dry hopped beer, just really maybe extending that conditioning time, especially if you're looking to bottle, because you don't want a re-ferment in the bottle.
That's what commercial brewers do as well. They sort of like, I mean, they're brewing all the time, so they get used to their hop creep and their hazies, and so they'll actually adjust their malt or their mash, knowing that they're allowing for hop creep, you know, because they have to hit the number, the ABV that's on their can. So they sort of just allow for it at a homebrew level. You know, if it's going to go a bit further, the alcohol is going to go a bit higher, beer's going to finish a bit drier. It's just something that's, you know, might not be a huge deal for you. It's just something to keep in mind in terms of your recipe design.
What are you typically seeing as a hop creep? Like, I mean, if you're talking an increase in ABV, you know, I mean, for a typical kind of, say, 10 to 20 gram per litre hopping rate in a hazy, what kind of ABV creep are you getting or seeing?
So yeah, for our main hazy strain, again, it does depend on how much hop you're adding. You know, there is a bit of variance there, but it can be it's from around sort of like 5 to 10% more attenuation. So could be half a percent to a percent, depending on how strong the starting gravity is, kind of thing. Yeah, which is obviously significant for commercial breweries when they have to hit particular excise targets and things like that. So yeah.
Is that at a fermentation temperature, or I guess what I was getting at with the lower temperatures is, will that limit the hop creep due to, you know, limited fermentation at that stage?
Not really, because like once those enzymes that are on the hops have been introduced and they're starting to like make those sugars, the remaining sugars, more fermentable. Like the colder temperatures just kind of
it'll slow it.
Slows it down.
Yeah,
you'll still see that like final gravity just slowly stepping down, but it won't sort of like ride it off, you know.
I guess through packaging and stuff, if it warms up later on or something, you might see that diacetyl.
Which could be problematic. Right, what are we at? We still got a little bit more time, Clive, to get through these last few questions.
Yeah, sorry, if you've got time, I'm sure we've got time. There's still 21 people on the call. That tells us it's all good.
Yeah, thanks for sticking around, team. We're almost there. Reese is asking, what price point will your yeast be? Yeah, so as we mentioned, we're sort of wanting to hit that 200 billion yeast cells homebrew pitch package, which is like twice as much yeast as you'll get in a white yeast pack, or like I think almost three times as much as a white yeast pack.
White labs. Yeah, 3 times as much as a white labs almost.
Yes, that's right. Sorry, yeah. So 200 billion rather than 100 billion or 50 billion in the case of white labs. The retail pricing we're aiming to hit is around like 27, 28 bucks. I know you pay like 20 for a
18 to 20.
18 to 20 for a white labs or something. So essentially you're getting twice as much yeast for $8 more. And so I suppose
it's going to be fresher as well. Because one problem I've had with getting stuff from the brew shops that's been shipped from overseas is it's kind of
5 month old.
approaching its best before date.
Yeah, there's not
And
much left in there.
Yeah, and it does seem to have a big impact on lag time and
It definitely
everything,
would. Yeah,
health. Yeah. So to have a fresh liquid yeast in New Zealand would be fantastic.
Yeah, it really kicks off, like, and it's super noticeable, and that's what we love is like when brewers get that proof in the pudding. We've definitely seen it with commercial brewers who are also used to getting like old, long overdue, maybe temperature fluctuated yeast slurry from overseas, and then they chuck ours in and kind of shit their pants because it's just like the whole thing sort of vibrating and puking on the floor, and it's it's quite exciting when a fermentation goes really well, and then of course the final product is just like, damn, that's the best batch of beer I've made, and all I've done different was the yeast. So yeah, we really love being part of that story. Brian's asking what percentage variance to ideal pitch starts to negatively impact ferment.
Oh yeah. So what percentage kind of lower can you go before you get negative impact? So our pitch rate of 200 billion cells for a homebrew, or 0.75 million cells per mil per degree Plato. That's best practice. White Labs pitch rates, as we've sort of discussed, they're about 0.3, so less. Yeah, what is that?
About half.
About half, or a bit lower. That, and by all means, that can still work in your brew. It just means that you'll have potentially extended lag times and things like that. I sort of think, being safe, you could go down to probably about 25% below what our recommended pitch rate is, and you'd still have a pretty good ferment.
And that's assuming that we're still talking about like fresh, healthy yeast. So another reason to sort of aim for that ideal pitch rate is that if there's other factors you're not aware of, like the yeast health is a bit poor, it just gives you more wiggle room to still nail it. But if those other factors are compounded, you've gone for the low end of pitch rate, your yeast happens to be a bit old, a bit unhealthy, and then all of a sudden, it doesn't really kick off, or you start spewing really nasty off flavors. You're just sort of placing your bets with each investment into better yeast health and better yeast population and performance.
Can I throw a comment on the White Labs one on that? Because I talked to Chris about this, and I mean, a big part of what their lower pitch rate thing was a higher vitality strategy, and that works fine and well when you sort of when your yeast is really, really fresh. But you got vitality and viability, and vitality really does drop off even faster logarithmically than viability does. So I mean, their idea of a reduced pitch rate was based on what they were getting when they were measuring like levels and other markers in the yeast that they were getting off being at a much higher vitality level, which is great, and you can get away with it when the yeast is really fresh. So if you're pitching stuff within a month, hey, look, it's awesome. But I know where they've been sort of struggling a bit is the impact that has once you start getting a couple of months into thing where, I mean, okay, your viability might be one thing, but your vitality is probably actually almost dropped, it's a square root of what it was when it started. So fresh yeast, that's, I think, again, getting hold of fresh yeast locally, awesome. Makes a massive diff.
Choice.
And for anyone who doesn't know, the difference between vitality and viability, just quickly. So viability, as we mentioned before, is the percentage of live versus dead cells in a population. Vitality is actually a measure of the health of your yeast population, which is normally measured through forced acidification. So it's measuring how rapidly yeast will drop the pH of usually a glucose solution in a set period of time. And basically, the more rapidly it acidifies it, the more vital and healthy that population is. So, cool.
Nice one. Clive asked, how do you go from your fermenter to a packaged yeast in your process, i.e. how do you lose dead
Yeah,
cells?
did you? I'm not sure you
Yeah.
covered this off. Maybe you did, and maybe I wasn't listening carefully enough.
I don't think we have.
Like you actually, like, you know, so we got as far as the fermenter, and you got excited about measuring the, you know, your fancy thing that you can measure all of the parameters across, you know. But then what happens next? How do you?
Yeah, in the same way that we saw that diagram with the bottom of the conical fermenter. Once our propagation is finished and we've reached our terminal gravity, we chill our tank as well to encourage the yeast to flocculate down to the bottom. And yeah, that usually happens over what, 2 or 3 days.
Yeah. Our glycol chill is not the gruntiest, so it's but yeah, we usually drop it down from about 20 degrees or lower depending on the strain to 0 is what we sort of bring our fermenter down to. That gets all the yeast to crash to the bottom. Then it goes from that fermenter. We transfer it through a sanitized line into a homogenizing packaging tank. So that's a packaging tank that has a stirring arm in there with a motor on top. So we transfer that through a flow meter and a sight glass. The first yeast that comes out is discarded to try and get anything that's been hanging out just in the exposed tube of the fermenter. We don't want to package that. Then once we get to the nice healthy looking yeast, we send that into our homogenizing tank where it gets stirred up. So it's all a nice even homogeneous mix. We then take samples from that for our cell counting and viability and vitality checks. And we actually do 6 different cell counts from that population, 3 from each of 2 different samples. And we take the average of that to get our cell count. Just so we've taken basically a wide spectrum of checks and found the average cell count from that parameter. So that's how and then from there, it gets packaged. We've got a kind of interesting looking sort of attachment of triclover fittings. And so we pressurize it with CO2 and it comes up and out of an arm with a valve on the end. And that's done into sterilized bottles under a Bunsen flame, which acts as an aseptic area. So the upward heat of a Bunsen flame will, by convection, prevent microbes and stuff from falling in. So yeah, that's sort of how we get it.
Oh yeah, you didn't cover that, did you? I didn't imagine.
No, we didn't.
That's fascinating.
Details we could dive into, but you know.
How are you guys doing accounts? How are you guys doing accounts? Just a hemacytometer or a microscope?
So we use a device called an Oculize, which is
cool.
you've seen that one. Yeah,
toys.
Yeah, toys. We were doing it by hemacytometer, but it's a lot quicker, a lot less hand counting, and a lot more accurate with the electronic stuff. So yeah,
it's old quick.
That's cool. That device.
Yeah, they're great. Those toys. Yeah.
Yeah, we're seeing a few more of them show up for some of the craft breweries around New Zealand, which is cool. Sort of, bit more pride and like attention to detail when it comes to yeast happening out.
Did they drop their licensing costs on it? Because it was pretty brutal a couple of years ago when I first saw it. Right at another time. Sorry.
It's not super cheap, but it's definitely a lot cheaper than the other closest automated cell counter, which when I got a quote was $28,000. So that one's a lot more available, a lot more affordable.
yeah, biohacking.
Yeah.
Well, Paul wants to know the story about the reindeer, or is it a moose behind us?
It is a moose.
It is a moose here. I used to live in Canada for a year in British Columbia, and picked that beautiful specimen up over there. So it's like really cool breweries in British Columbia too. Kind of similar brew scene to Wellington, I found, in terms of like scale and like brewery size and stuff like that. Yeah, really cool stuff there. The who spawned for the win. Yeah. Can you name a few of the mainstream breweries you're using who are using your yeast? yeah, so we're supplying about 40 craft breweries around the country now. We can name a few of them.
Yeah, I think so.
Yeah, I mean, Garage Project has been a early supporter of ours. Sawmill up in Matakana, Three Sisters in Taranaki, Waitoa and Hataitai here in Wellington. Deep Creek up your guys' ways. Te Aro in Upper Hutt. Double Vision, our buddies here in Miramar. Emerson's, yeah, have been awesome customers of ours and using a few of our strains across the board. Yeah, our hazy strain is now their main house strain there. And yeah, a few small ones dotted around the country. There's a lot of them, these small sort of, what are they, 4, 5, 600 litre kind of nano breweries and more like rural New Zealand, but with like strong sort of local followings. There's quite a lot of those out there.
Hey, I didn't realize you guys are based in Miramar.
We are in Lower Hutt.
Oh, sorry, right.
But yeah,
I thought
double
you said
vision
Miramar.
is
Double Vision, yeah.
on our way home.
But where we are now
my-
at our home is an island bay, so not far from Miramar.
Yeah, my in-laws live in Miramar, and last time I was
nice.
there, I went to Double Vision Brewery. That was
Nice one.
very good.
Then there's Alibi on Waiheke, if you've ever been across there to see those guys. Urbanaut.
Yeah, yep.
Yeah, the boys at Urbanaut. And yeah, a few others.
Yeah,
The list goes on.
that's a few of them.
Cool.
What temperature do you recommend running your yeast starter at, and for how long before using it or stepping up to the next size starter? So yeah, as I mentioned, best practice would be to kind of grow your starter at a temperature similar or at what you're going to pitch it into, just so that it gets acclimatized. You can go as warm as like 27, 28 degrees. That will get your growth rate faster, without any real negative impact. And I guess, yeah, you really want to go and pitch that while the starter is active. So I would say within 24 hours. Yeah, and you should see good. This is based on us having like pretty strong oxygenation and things like that. So yeah, provided that you're getting good O2 in there, whether that's like a stir bar or like shaking it as frequently as you can. I would say, yeah, at a minimum, probably 24 hours. Probably you could go 24 through to 48.
Yeah, as long as it's still active.
Yeah.
Because yeah, once it sort of starts to taper off, I mean, you want to get it into your wort so that it's gonna have a big feed and do the job.
Yeah.
If you're pitching it active, you're not decanting either, are you?
That's right.
Yeah. So yeah, if you and by all means, if you want to drop the yeast out of suspension and then decant off your wort, you can certainly do that as well. And you can either start cooling that starter mid ferment, if you want to, if you're able to get it down cold and you can arrest that fermentation, or let it go to the full, say, 48 hours and then cool it and decant your wort and then pitch the thicker slurry in without much issue. Yeah.
If you crash it before you pitch like that, though, I mean, you're going to end up with glycogen issues when it basically restarts into your wort.
I mean, actually, cooling your yeast, if you want to cool it, you can let it go that sort of full 48 hours ferment in the starter, and then cooling it and holding it there at below 4 degrees for 24 to 48 hours will help it build up like trehalose and glycogen and things, which will actually help with the storage of yeast in cold temps. So it shouldn't have a negative impact on.
It was more if you're going to stunt it at 24 hours. That was my concern.
Right. Yeah.
Is that the Brewers Lounge at Alibi behind you.
Yeah,
Yeah.
it's always topical. It's the
Yeah,
coolest bar around.
It's
If you guys haven't been out there, the taps come out of the ceiling and kind of just float over the bar.
That was the Brewers Lounge was closed when I was there because of COVID, but I was upstairs at Tantalus.
Oh, it's not a bad place to be either.
Yeah, it's pretty beautiful. Nice, a nice wee brewery there too.
Cool.
And it's a pretty cunning brewer as well.
Bernard.
Yeah. Good boys.
Right on.
All
That
right.
brings us to the end of our questions, and I think the end of our time. We've had a good couple of hours discussion there. So yeah, thanks everyone for tuning in. I hope you learned something.
Well,
think we
Kapai
learned
Ryan, Kapai.
Yeah.
Thanks very much, guys.
That was awesome, guys.